Hello guys, and welcome to my 5th video on integration. Today we look at developing our previous lesson on finding the area under curves. And today we're going to be looking at a specific example from a past exam paper. And this is a real question that I've taken. And it says find the area enclosed by the curve y equals x squared, the line y equals 2 minus x, and the x-axis. So here's a diagram that we were given. And it's telling us to find the area A, which is under a curve and a line. And we're given these points, 1, 2 and 1, 2, on the x and y axis. So, the first thing we need to find in this kind of question is the point of intersection. We're not told what this point is. We can see from the diagram it looks to be 1, 1, okay? I've not drawn that exactly as it appears in the exam, but it should be 1, 1. But it never tells us that. Okay, the question never tells us that the point of intersection is 1, 1. So we need to find this point of intersection. So to do that, all we use is substitution. We know that they're going to be equal to each other at this point, so we simply substitute in one of these terms into the other equation. So, if y is x squared, then we can replace the y in this equation with x squared. Okay, since y is x squared. X squared is 2 minus x. Now we need to get all these terms on one side, so we're going to get a quadratic equal to 0, which we can factorise. So we can move this negative x over here to make it positive, and we can move this 2 over this side to make it negative. And this is going to equal 0 since we've moved all the terms across. Now we can factorise this. So we're going to get plus 2 and minus 1. Okay? 2 multiplied by minus 1 gives us minus 2. 2 multiplied by x, 2x, minus x. 2x minus x is plus x. X multiplied by x gives us the x squared. Okay? And this is equal to 0. So now what we need to do is make each bracket equal to 0, so we can find the x coordinates. So if x plus 2 equals 0, then we can say that x is minus 2. And if x minus 1 is 0, then x is 1. Now, we can see by the diagram we want this area A. There's going to be 2 points of intersection because this is going to be a curve that's going to touch the line at around this point. If you imagine the line's going to continue in that direction and the curve's going to slope up like that, so we're going to get an intersection where x is minus 2. We're not interested in this point of intersection, however. Okay? All we're interested in is when x is 1. So we can find this point here. So if we have the x value, it's always worth finding the y value as well. We don't know if we need it yet, but we may well do. So, let's substitute x is 1 into any of these equations. Because at the point of intersection, it's where the two functions meet. So it doesn't matter which function, which equation we sub our x value into. We'll get the same answer. Just to prove that, if we sub in 1 into here, y is 1 squared, so y is 1. Okay? And if we put it into here, y is 2 minus x, so y is 2 minus 1, so y is 1. Okay? So we know that our point of intersection is 1, 1. Right, that's our first step. So the next thing to do, now we've proved that this is the point of intersection, is to find the area to the left of where x is 1. This is the area under the curve, okay, to the left. And it's part of A. Now, if we're looking to this area here, we're looking between where x is 0, the origin, and where x is 1. So we simply integrate between these two limits to find the area under the curve y equals x squared. So we're integrating between 0 and 1, which is the area under the curve. And we're integrating x squared, because that's the curve equation. So if we integrate x squared, we get x to the power 3 divided by our new power, 3. The next thing to do is to substitute in our upper limit, and then we're going to subtract from that our lower limit answer. Okay. So 1 cubed is 1, divided by 3 is a third. Now substituting in 0. 0 cubed is 0, divided by 3 is 0. So we're subtracting 0 from a third, which of course is just going to leave us with a third. So this is the area to the left of where x is 1, the area enclosed by the x-axis and the curve. Now, the next thing we need to do is to consider the line. Okay? So, considering the line. Well, you can see that this line and the x-axis is going to create a triangle to the right of where x is 1. The width of the triangle, the base, is a distance of 1, and the height is a distance of 1. So if we multiply 1 by 1, we get 1. Then we have to divide by 2 to get the area of the triangle. 1 divided by 2 is a half. So this is going to be the area to the right of where x is 1, the area of the triangle. This is part of A. I've wrote it up here because what I'm going to do now is actually integrate, because this is what the question is about. It's about integration. I just want to show you how we would do the same thing using integration. So, we're now integrating between the points 1 and 2. Okay, the area under the line. And we're integrating this function now, the line function. 2 minus x. So the first thing to do, once again, is to integrate that. So 2 becomes 2x. And minus x becomes minus x squared divided by 2. Now we need to substitute in our upper limit of 2. So, 2 multiplied by 2 is 4. Minus 2 squared is 4. Divided by 2 is 2. 4 minus 2 is just 2. Now, substituting in our lower limit of 1. 1 times 2 is 2. Minus 1 squared, that's 1. Divided by 2, a half. 2 minus a half is 3 over 2. 1.5, okay? So, as always, if we're finding the value of a definite integral, so the area between these 2 points, under the line, then we are subtracting our lower limit answer from our upper limit answer. So 3 over 2 subtracted from 2 gives us a half, okay? 2 minus 1.5. It's a half. Okay? Which is what we got up here. So that's just proved that that is the answer. So now we can be confident with our answer to this part and this part. And these are both parts of the areas of A. So now if we want to find the total area of A, we simply add these two together. Well, a half can become 3 over 6, and a third can become 2 over 6. Adding 3 over 6 and 2 over 6, we get 5 over 6. This is our answer, okay? This is the area of A. The area enclosed by the curve, line and the x-axis. So hopefully you've followed every step there. If you have any questions, please put a comment below. And if you haven't already, please subscribe to my channel. And if you found this video helpful, please put a like. Thanks a lot, guys. I'll see you in lesson 6.